So this question involves a rate. When I see rate, I know I need to differentiate with respect to t. So that's my function. When I differentiate, I get 58 e to the power times my power differentiated. I don't need to tidy it up. I'm simply going to substitute in t is 4, putting it carefully into my calculator, answer to two significant figures, minus 5.1. Then we've got a second substance. I'm going to call that n. When it's increasing exponentially, I get a function of this form. When the time is 0, my mass is 42. Now when I put t is 0 in here, e to the 0 is 1, so I just get n is a. So when t is 0, n is a, and I want that to equal 42. So a must equal 42. After 6 years, so when t is 6, I've got my function n equals 42 e to the kt, that was my a I just found. When t is 6, the mass is 51.8, so I put that in, I get rearrange e to the 6k, so 6k is ln of that. Okay, and I can put that in my calculator. I'll get whatever value I get, I'll just keep it on my calculator. Find the mass at time 24 years. So now I'm putting t is 24. Now I actually did this non-calculator to start with, which is why I didn't write down k, but you certainly can. So 24k is find the mass at time 24 after the initial value. 24k, pause. Okay, so what I did here, because I didn't have a calculator handy, I just did a little trick. Most of you will probably just go straight here. What I said was if that's 6k, times it by 4 to get 24k. Okay, so I've got 4 times this previous answer is 24k, but most of you will have used a calculator. So n is 42 e, the 24k. You're probably using a decimal there, decimal value, typing it in, final answer 97.2 grams. It doesn't tell us how to round, so we go for the general rule of 3 significant figures.